we have already done the coordinate unity at any point P. XY. So what is XY? It is an ordered pair. You have plotted it.
Yes, sir.
Next dimension, right? So now you want to plot a complex number x plus iy in a quadrant. So try to match it. Okay, try to match it. Suppose x, what is x? Draw it here perpendicular. This length is y, right? And this length is x. So draw it at PM. So length PM goes to what? Y, and OM equals to x. Now if you want to compare with complex number, if you take the x-axis as real axis, and this as imaginary axis. Okay, so if you take x-axis as real axis and y-axis as imaginary axis, then x is the real part. So that you can plot according in the real axis, and then y that you can plot in the along imaginary axis. So that point p x y we can represent a complex number also. So this way of representation, where we are comparing x-axis as real axis and y-axis as imaginary axis, this type of representation is called Argand representation or Argand diagram, and this plane is called Argand plane. Okay, so that means through Argand plane we can represent any complex number. And there is another way of representation of a complex number, that is called polar representation. Now, same thing. So that origin will take as pole. This will take as pole. Okay. Now this point, suppose same point Pxy we want to represent through polar representation. So only the one point fixed point will be as pole, and one initial line along. Suppose this one is called in that case initial line. Now if we join this one, OP. Okay, so what is OP? Root over of x square plus y square. X, y, so we apply Pythagoras theorem. This is x what? That is actually mod of this. This is what? Root over of x square plus y square. That means this length OP is the modulus of that complex number. So this length OP represents as the modulus, and the angle it makes with initial length. So this angle is marked as beta, or this we can write as r. Then that point P can be represented as r theta, where r is the modulus of that complex number, and theta is called the argument of that complex number. Theta is the angle made by the line of P with the initial x-axis. Okay, clear?